Okay, hi folks. This is activity 3 in lab number 3. And in fact, this geometry, we already created it in an earlier lab. But now we're going to go back to it because what I would like to do is to fix the edge, this bottom edge, I would like to fix it all the way around and then apply a total force of 500 pounds on that little stand. Okay. So, a couple of things. I will be asking you to use as many planes of symmetry as possible. Okay. And this is the way it's going to be on the midterm and the final exam. So, if you look at this problem, actually, what you need to do is model only because of symmetry. You have two choices: model one piece like that, which is 60 degrees, right? 60 degrees. Or you can do 60 degrees this way, okay? That's entirely up to you. You can do 60 degrees by cutting it like so from here. Uh, Hang in there. No, I'm sorry. Uh, so the symmetry is involved taking a 60-degree angle like that. Okay. Now, could I have done 60 degrees this way? The answer is no. Because when you think about this thing, uh, when you think about this, you can take this. If you're asked to take the smallest piece, it's going to be 60 degrees like so. See that? But if you take 100 degrees, you can take 120 degrees, but that is not the smallest piece. If you take 120 degrees by cutting it 60 degrees this way, 60 degrees that way, yes, this is fine, but it's not the smallest piece. The smallest piece that you need to do is to take actually one cut like that all the way down here and cut it in that location. Okay. So that's what I'm going to do. That's what I'm going to do. Okay. All right. Now, just like I did it in class, first I'm going to create the entire model. This is crazy because if I'm going to cut it, why would I create the entire model? I'm going to create the entire model so that you recall some of those features that we used, but then I'm going to cut it with the appropriate plane later on. All right? So let me see if I can remember these dimensions. This is made with steel with default material properties, so you can use the material properties in Catia, except that you don't have to change it. Default material properties are fine. All right, let's go ahead and do that. We start with the Catia file, file, new part. Immediately save it. I already created a folder there. File, save management, save as. Now, I created a folder called Activity 3 Lab 3 in there. I'm going to call part problem 3. Please make sure you don't overwrite parts when you write test and final exam. All right, so on this plane, I will sketch a circle, and I believe the diameter of that big circle, radius of that big circle is, can't remember, 10 inches. Radius is 10 inches. Yep. Diameter 20. Okay. Oops. 20. Okay. Fit it. This is fit. Okay. Fit it. in the class when I did this thing in an earlier activity that the video is already posted, I use a multi-pad, but I'm not going to do it like that. Okay, I'll just use the pad. So exit. Oh, this circle, see that? Because I want to make a hole, I will draw a circle here too. Because I want to make a hole. That's one way. Make a pocket. That's one way of doing it. First of all, the distance from the diameter of this is, if you look at the drawings here, the diameter, radius is 1, diameter 2, okay? And it's positioned 7 inches away from the center. So, so let's see now, dimension from the center to that point is 7. Oh, this is going to cause a problem. If you do it like that, mm, yeah, you know what? I'm going to cancel this. I'm going to delete that. I'm going to delete this. Let me delete this point too. Exit, padded. There are many ways of doing this problem. I was going to go that route, but I will let you decide how you want to do that. You pad 2. There we are. On that face, I will sketch. Now that circle that I drew over here, the diameter 2, and the distance from this point to that point, 7. 7. Okay. Exit, pocket. There's the pocket. Pocket that sketch. Okay. Pocket all the way to the end. And now I'm going to do a circular pattern of this pocket around that a complete crown around that part. So where is the pattern here? There's two ways: rectangular pattern, circular, and arbitrary. Circular. Read it carefully. I want to do a complete crown. Axial, complete crown. See that? Axial right there. Axial tab. Complete crown. Three instances of what reference? Well, of what is it that I want to pocket? What is it that I want to pattern? Is this pocket that I want to pattern? And what is the reference element? Reference element basically this circular. If you take that circular face, it will do it around the axis of that circular face. There we are, and we say okay. It's crazy because in a few minutes I'm going to cut this thing, but on that face I will sketch a circle to make that little stand in the middle. And what is the radius of that circle or diameter of it? It looks like that is, or the look of it, let me see, uh, radius 2 inches. Okay, radius 2 inches. So diameter 4 or radius 2. Excellent. Exit, padded up by the amount which seems to be 1 inches in the drawing. 1 inch in the drawing. There we are. And let's apply material properties to it. Properties are metal. I think it says steel. Yep, steel. So we're here on that part, and we say okay, and we save. It's crazy now because I want to cut. I want to cut this thing to get only a to get the smallest piece, to get a 60-degree sector here. Now, one of the planes, let me see, how did I draw this thing? One of them I already have, like I can cut, if you look at the view from the, oh yeah, if you look at the view from the top, this plane can be used to cut this. But I also need a plane at an angle with respect to this. So let's try to do that. So I'm going to do a plane. Just be careful here. You do it any way you want. This is how I'm going to propose to you. Plane. And the method that you're going to use is called, let's see now, hold on, offset, angle, normal to a plane. Let's see now. Let's see. Offset from a plane, no. Parallel through a point, no. Angle normal to a plane. This is what you want. Click on it. It's asking you for a few things. Rotation axis, Z axis. Right click Z. Reference is that plane that I want to rotate. And 60 degrees is by how much? Preview. You see that? It created this plane at 60 degree to that reference plane that I selected. Good. Now we're going to cut it. So use the mirror cut. Let's cut it with this. On which side? No, not mirror. Sorry, cancel, not mirror. Split right there, right there. Surface base feature. Saw, the saw. Okay, let's try it. We want to cut it with this plane. Doesn't matter which side we take. That's good. And then we want to split it with this tilted angle. We want to see, I'll keep the other side there. So that is a 60 degree slice that I wanted to. I could have made this thing from the very beginning. Okay. So save everything. And now we're going to do and go to the generative structure analysis. We want to do a static analysis. Okay. And by the way, you can make finer mesh around this hole if you want. So as a reminder, not a reminder, this is the first time you're going to see it, but let me do the following. Let me do the following. So suppose I want to stick a finer mesh around this hole. So if you look in this toolbar, if you look in this toolbar, and if you expand this icon says local mesh size. You click on that, and then it says, where do you want to refine? So around this hole, and by how much? So let me make it 0.2. Say OK. You see, around that hole, the mesh size is this. Everywhere else is different. So if you look at your mesh, right-click mesh visualization. This is how you do local mesh refinement, and I will ask you to do something like that on a test for sure. Okay, there it is. Finer here, bigger there. And then deactivate. Proceed with the rest of the problem. Okay, planes of symmetry. This and that and the one in the back, these are roller supports. Okay, so we go with surface slider on this face and on that face and turn it around on this face. You can do 3 of them separately if you want, but this is crazy. Okay, I did all in one. We are told that this bottom edge is clamped. See that bottom edge is completely clamped. So you click on this clamp, just the bottom edge, just the bottom edge. Okay, and then we say okay. And then you're also told that a total force of 500 pounds is applied there. But we're taking 1/3 of that, so it's going to be 500 over 3. This is the force. You have to divide it. If it was a pressure, you would not divide. So 500 divided by 3. So we go here. Force, look for force. This is pressure. This is force. You click on it. You select that face. Uh, did I say divided by 3? Sorry, divided by 6. That's what I meant. Because we're taking a 60-degree sector, 500 on the whole thing, which is 360 degrees. We're taking a 60-degree sector, so that's going to be 500 divided by 6. So in the Z direction, 500, negative 500 divided by 6. You can do that. I'm just going to turn it into the right value. You can see right here on that face in the negative direction, and we say OK. And let me save this thing. Files, files, save management. Analysis I haven't saved yet. Save as. in the right folder, which goes gonna go up, activity 3, or solid, or call it problem 3, okay? Problem 3, we say okay, and okay, and I'm gonna run it. Calculator, right here, calculator, compute. Ignore this because in all likelihood you guys don't get it. I don't get it on my other laptop either. Okay, let's see. Deflection or deformation looks like that. Animate makes sense, right? Because this edge is fixed. These edges do not change shape. There's a roller support, and this thing goes down. You want to look at the displacement, you click on displacement. Very small, these are gigantic, bulky thing. You click on this icon either anywhere on these arrows or from the tree. You can click on the on this line too. Let me cancel that. See, you either put it there, but as soon as you put the cursor there, this thing lights up. So you can double click here, or you can double click on these arrows under visualization, average ISO, and make sure the rendering is material shading. It is. There we are. And very tiny amount of deflections. But stresses are going to be pretty high probably down here because well, let's find out. Let's find out. In all likelihood, it's going to be high there. So look at the one meter stress. Yeah, you can see that because there's no way you can hold an edge, fix it. There's no way, no way. And now these are masking, these stresses are masking basically other stresses. That's why it looks like that. By the way, there's something called cutting plane. You know what? Let me do the following. Let me actually stay away. Let me stay away from these edges, show you the stress distribution there. You can't see it here, it's all blue because they're so much smaller compared to these. But let me first show you the cutting plane. There's a cutting plane. You can cut this thing and look at the inside of this part. See that? You can look at the inside of the part. But these numbers don't change though. You can see that by rotating, looking inside does not, help you to know what the values are there. Okay. Incidentally, you can say, don't show me the cutting plane. See that? All right, that's what this thing is. But what I want to do, I want to look at the stresses here. So let me deactivate this and make a group. This is a good place. Nope. I'm going to resize that. You have to click on this guy. This is the inactive box. Now we activate it. We put it where we want, and we resize it as we want. So let me put it there. Yeah, I don't want to go all the way down because that defeats the purpose. So let's look at for example, the elements in this area, in whatever is enclosed there. So we say, okay, if you want, you can hide the box and double click on the Van Mises stress, select the selections, box group. Just show me the stuff in the box group. I mean, these are terrible. It's so small that it really doesn't make any difference, but there's nothing. If you want to see everything back, double click and say show me everything. All right, that takes care of reference number, problem number 3, activity number 3.